All right, let's do some Mathity-Math. Now, usually I get my pencil and my eraser, but all of my pencils and my erasers have disappeared. So today, against my own advice, I will be doing this with a pen and just hoping that I don't make any mistakes. Here's hoping, and here we go. This practice test is all about quadratics, and it is for my MYP4 class. That is a 9th grade math. Here we go. So we are given a quadratic out the gate. Y equals x squared plus 7x plus 12. And the first question says to us, well, what is the vertex of the quadratic? Now, the vertex of the quadratic is the high point or the low point. So I'm just going to write an A right here. I'll just show my work here. Now, because we are in standard form and we're going to try and find the vertex, we can actually just use this formula right here to help us find x value that is the vertex, and that'll eventually help us with the axis of symmetry. So anywho, this will help us find the x value of our vertex, okay? So I'm gonna write that right here so I can use it. So I know that x is equal to a negative b over 2a, okay? So that's where we are at. Now looking here, the coefficient here that you can't, there's nothing there, so that's a 1. So my a value is 1, and my b value here is 7. So essentially what I have here is negative. So instead of b, I write 7 over 2 times 1, because that 1's right there, so that's just 2. Okay, so long story short, the x value of my vertex is going to be negative 7 over 2, or you can call that negative 3.5. Okay, so now what do you do with this? Well, remember, x values are inputs, right? So you can actually input this x value here, substitute it in, and what that is saying is, you know, when I stick in negative 3.5, what comes out as a y? And that's called your output. Well, that'll give you the y value, and then you'll have the coordinates of your vertex, okay? So just to make this very, very clear here, down here we would have y equals x squared plus 7x plus 12. That's just my given quadratic. And all I'm going to do is substitute in this x value. So instead, I'd have y is negative 3.5 squared plus 7 times 3.5 plus 12. There you go. And then we can just do this work, and then we will have the answer for part A. We will know the coordinates of our vertex. And let's see here. I'll get my calculator so I can be really clear about this. So we have negative 3.5 times negative 3.5, so 12.25, so that's this, 12.25, plus, oh, you know what? I made a little mistake there. Let's be careful there. It's a negative. Whoopsie, whoopsie. Okay, try that again. So it'd be 7 times 3.5. There you go. Negative 24.5, and then plus 12. So there you go. You add all those up. I guess I can do that for you right here. Let's get a good, let's see. There we go. That looks nice. Okay, so let's add those. 12.25 plus negative 24.5 plus 12, ta-da, we get a negative 0.25. So we know that when we input negative 3.5, the output will be negative 0.25. And that right there is actually the coordinates of the vertex of our quadratic. So the vertex of our quadratic is negative 3.5 and negative 0.25. There you go. And actually, I'm going to jump down to question C here. It says, well, what is the equation of the axis of symmetry? Well, the axis of symmetry is just a imaginary vertical line that passes through the x coordinate of our vertex. So the equation of our axis of symmetry is right here. It's just going to be x equals negative 3.5. There you go. Okay, let's do question B. I'll put it right here. And question B just says, what are the x-intercepts of the quadratic? This question might be rewritten like, what are the solutions of the quadratic? What are the roots of this quadratic? But long story short, it's where does your parabola cross the x-axis? Okay, so I'm going to rewrite my work right here. So I have x squared, I'm sorry, rewrite my quadratic, not my work. X squared plus 7x plus 12. Okay, to factor this, I'm a big fan of using the AC method. So A is 1 and C is 12. 1 times 12 is 12. Okay, and so then we think about factors of 12 that when added together give us 7. So 1 and 12 is 13, that doesn't work. 2 and 6 is 8, that doesn't work. But 3 and 4, that does work. See, 3 plus 4 is 7, and 3 times 4 is 12. Voila. So you take this 3 and you take this 4, and actually all you're doing is rewriting this b by splitting it into two pieces. So I say 3x plus 4x plus 12. And in reality, you see here, nothing is actually changed. Instead of 7, I just wrote 3 plus 4, and 3 plus 4 is 7. So nothing's changed. Okay. I put some brackets here, okay? And then all I have to do here is factor both of these binomials, and I will be in business. So this one only can take out an x. So there you go. So you're just gonna get x plus 3. And this right here can only take out a 4. You'll get x plus 3. And that's how you know you did it right, because you know you have matching binomials. And that lets us say, well, now because of this, I know that my factored idea is x plus 4. This is my factorized form, x plus 4 times x plus 3. And this all works because of the commutative nature of multiplication and addition. Okay, using the zero product property, set that equal to 0. Is essentially using ZPP or zero product property. I know x plus 4 is 0, and I know x plus 3 is 0. So x equals -4 and x equals -3. Ta-da! And that is your answer to B. Those are your x-intercepts. And the coordinates would be -4, 0 and -3, 0. Okay. Back to question C. We already did that one. Never mind. D. Describe the parabola in terms of how it opens and its vertex. Okay, so that just really comes to here. Okay, so this value, the value of A, is positive. So that means, let me just draw like a little secret cheat sheet up here. Okay, if A is positive, your parabola will look like this. Ta-da! If A is negative, your parabola will look like this. Ta-da! Okay, so because my A is positive, my parabola opens up, and my vertex is a minimum, okay? And if it was the other way around, my parabola would open down, and my vertex would be a maximum. So, looking at that, understanding that A is positive, how would I describe this parabola? I would say it opens up, and the vertex is a minimum. Ta-da! Okie dokie. All right, last one says sketch the parabola. I'm gonna do that right over here. I got some nice space here, so let's go for it. Okay, you may notice that I am on a new sheet of paper. That's because I made a mistake sketching my other parabola, and I don't have an eraser because people borrowed them and never returned them, along with my pencils. So let me start this over. As I was saying, X and Y, okay? There you go. And then we already did all the work earlier to show that our x-intercepts were at -4 and -3. 1, 2, 3, 4. There's -4. There's -3. -4. -3. I'm labeling those points. That's a big, big move. Go ahead and sketch this parabola. It's going to come up like that. You know, not the best sketch in the world, but it'll get there. You know what? Actually, I'm going to go ahead and extend this up because actually you can also show that you would know the y-intercept because that's going to give you from that value right there. So my y-intercept is over 0 up 12, right? Because that's what C tells us. Anywho, back to business. Okay, right here is my vertex. And earlier on question A, you said, or we said together, that we know that's negative 3.5 and negative 0.25. That's from the previous work. I can go ahead and put in the axis of symmetry. That is x equals negative 3.5. That's that right there. And actually, I think that's all the stuff we need. We have our y-intercept, our two x-intercepts. We have our minimum with the vertex, which is a minimum. And I have the equation of my axis of symmetry. And voila! Question 1 is in the books. Boom! Let's keep it moving. Okay. Question 2 says, let's write this thing in expanded form. Okay, no problem. Here's a nice little question here. So basically, you just need to multiply these two binomials. And how that works is you take your first term, which is an x, and it's going to multiply to this x. Okay, so that's x times x is x squared. Fantastic. This x then multiplies to the 2. Well, what is x times 2? Well, 2x. Yay! Keep it moving. Move on to the next term. This 3 multiplies by that x. That gives you 3x. Woohoo! And this 3 multiplies by that 2. 3 times 2 is 6. Right there, you guys are almost all done. And then if you just combine your like terms, which is an important step, you get x squared plus 5x plus 6. Huzzah! Happy day, you are done. Now, it may seem like a trick, but you know, it was a nice connection. Look, the answer to here is the actual next question. I want you guys to see the connection that, you know, factoring and expanding are just the opposites of each other. So now it asks us to factor this quadratic, in which we can do real quick. Again, for me, I like to use the AC method just because it's fast and easy for me. So 1, that's A, 6, that's C. A times C is 6. This is a nice straightforward one. Just think about factors of 6 that will add up to 5. Let's see, 1 and 6. 1 plus 6 is 7. Nope. 2 times 3. 2 plus 3 is 5, and 2 times 3 is 6. Yay, we did it. So I'm just going to quickly rewrite my 5x as 2x plus 3x plus 6. Put some parentheses here, and then we just factor quickly, okay? So all these guys have here is an x. So that's just going to be x, and I get x plus 2. This one just has a 3, and then I get x plus 2. Quick check. These right here, I'll put a little squiggly line. These are the same, so we know we're in the right path. So here we go. You get x plus 3 and x plus 2. And now this is the part. A lot of the practice tests that I gave feedback on, a lot of us got this far. And that's unfortunate that you did all this work and didn't identify the roots, right? So you need to show that you understand the zero product property, and then you need to take the time to show that x plus 3 is 0 and x plus 2 is 0. Therefore, the first root is x is negative 3, and the next one is x is negative 2. And remember, this is just where your parabola crosses the x-axis. All right. Moving on. It says use the quadratic equation to find the x-intercepts of this quadratic. Okay, so the quadratic equation, I'll give that to you. It's right here. Right here, right? So this will give you the x-intercepts, the roots, the solutions. We've been talking about these a lot. It's right here, negative b plus or minus the square root of b squared minus 4ac over 2a. It's just a substitution game and some careful calculation. So first things first, I do like to take a second and list out my ABCs. A is 1, B is 4, C is 3. So now I know exactly what I'm substituting. Okay, I'm going to write my formula down and then just start substituting. So here we go. As I remember it from when I was your age, here we go. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all over 2a. All right, here we go. Let's fill those things in. All right, so b is 4. So instead of b, I write 4 plus or minus the square root of 4 squared minus 4. Okay, a is 1 and c is 3, all over 2 times 1. Okay, and that's just me showing some nice levels of substitution, okay? No big deal. And now just take a second and do the math that can be done to simplify this piece, and we'll go from there, okay? So a negative times 4 gives me a negative 4 plus or minus the square root. Okay, 4 squared is 16 minus, okay, 4 times 1 is 4, 4 times 3 is 12, so minus 12 over 2. Okay, let's do another round of simplification. I know this is a bit much, but let's just make it super clear. Here we go. Yeah, put these here to show my lines. Okay, next one, real fast. Here we go. Negative 4 plus or minus the square root of 4 over 2. Okay, one more time. Negative 4 plus or minus, what's the square root of 4? Well, that's just 2. 2 over 2. And now this kind of goes into 2 directions. We can do one with the plus and one with the minus. So the first one is going to be negative 4 plus 2 over 2. And the second one down here is going to be negative 4 minus 2 over 2. Okay? And here we go. Negative 4 plus 2 is negative 2. And negative 2 divided by 2 is negative 1. Down here, negative 4 minus 2 is negative 6. Negative 6 divided by 2 is negative 3. And there you have found your roots. And if I'm going to rewrite it right here to show like a really nice answer, it should be x equals negative 1, x equals negative 3. That's a good, solid answer. You have identified the roots. Ta-da! Move on to question number 5. Whee!